In this molecule, we have highlighted 4 atoms, and we need to rank them by charge, negative to positive, left to right. Firstly, we want to take note of each atom we're pointing to and the atoms directly bonded to them. For instance, number 4 is a carbon atom, and it's directly bonded to 2 carbons and 1 hydrogen. Then, we want to take into account the electronegativities of each element in play, including the 4 of interest and the atoms directly bonded to each of them. For instance, we care about the electronegativity of our oxygen, number 2, as well as the electronegativities of the carbon and the hydrogen directly bonded to it. Atom 1 and 2 are the hydrogen and oxygen respectively, and since they are directly attached to each other, we'll tackle them at the same time. The bond they form has a relatively large electronegativity difference of 1.4 units, where oxygen is much stronger at attracting electrons, so it acquires a partial negative charge and hydrogen a partial positive charge. It's noteworthy that this oxygen is also directly bonded to carbon, and the fact that oxygen's electronegativity is also greater than carbon's electronegativity, albeit not by as much compared to hydrogen, that's simply further evidence that our oxygen will be partially negative. And with that, we already know that A is the wrong answer, because we've just established that our 1 hydrogen is more positive than our 2 oxygen. So it makes no sense to say that the 1 atom is more negative than the 2. If we look at the carbon in the ring, atom number 4, we see that it's attached to 2 carbons and a hydrogen. Based on the electronegativity differences of the bonds, or lack thereof, it's pretty clear that there is not going to be much polarization of charge. There's not going to be much electrons which are going to be skewing towards or away from our carbon, so it's going to be fairly neutral. It'll be ever so slightly negative just because it's in a bond with hydrogen, which has a lower electronegativity. So we can establish a relative charge comparison between atoms 1, 2, and 4. 2 we know is negative, 1 we know is positive, and 4 is categorically 0. I mean, it's partially negative, but by such a minuscule amount that we're just going to call it 0. That in practice, it's neutral. So that means that we can also get rid of answer choice D, because it doesn't have the 2 to 4 to 1 order. And with that, B and C, it's just a matter of where does 3 fall? Is it over here or is it over here? Carbon number 3 forms 4 different bonds, 3 with carbons, so there's not going to be any electronegativity difference, but it forms also with an oxygen. And because oxygen is far more electronegative than the carbon, it's going to withdraw electron density from that carbon, giving it a partial positive charge. Therefore, B must be our correct answer, because a slightly positive carbon, carbon number 3, is going to be more positive than our neutral carbon 4, but less positive than our very electropositive hydrogen atom 1.